Hello dear children, hope you are at the best of your health and you have already started preparing for your 10th examinations. Myself Praveen, I am a Sadhana tutor. Here in Sadhana we have come here to help you in these subject lessons. Today I will be teaching you some concepts of arithmetic progressions in mathematics. Now let us start the lesson. This is the first lesson in your textbook, right? Now for the benefit of dividing the syllabus, we have already made the entire syllabus, that is 15 chapters in mathematics, into 7 different themes, right? So in this Sampada, the mathematics learning system, we will be discussing about all the 7 themes. Now just look at the first theme. The first theme comprises of number system, and the chapter here which is considered is the real numbers. And the second theme is algebra, wherein it contains arithmetic progressions, linear equations in 2 variables, polynomials and quadratic equations. And the geometry theme, as you know, we have triangles, circles and constructions. And in the coordinate geometry theme, we have only coordinate geometry. And then in the trigonometry theme, we have introduction to trigonometry and some applications of trigonometry. Statistics and probability comprise of 2 lessons, which are statistics and probability. And ultimately we have surface area and volume, and here we have only 2 lessons, area related to circles and surface area and volume. So we shall dig deeper into these concepts once when we finish all the syllabus and all the chapters. So once you gain confidence in the chapters, then we can switch over to the question paper pattern and the theme representation. So totally the entire textbook will comprise of some 80 questions in your 80 marks questions in your question paper. So we are here, the entire Sadhana team is with you to help you to score more and more marks in your SSLC examinations in all the subjects. Now let us restart our mathematics lessons, and the very first lesson that we are going to consider today is the arithmetic progressions. Dear children, you have already known the numbers and different types of numbers. Now 2, 4, 6, 8, 10, 12, of course these are even numbers that you know. This is a very special number. In the similar way, we have one set of number called odd numbers like 1, 3, 5, 7, 9. So once if I give you 1 or 2 numbers of this kind, you will be able to find out the rest of the numbers till the end, right? How is that possible? Have you ever thought of that? That is possible only because the numbers that you are listing in the set follow a certain pattern. And once you follow a certain pattern and once you list the numbers according to a pattern, it becomes a sequence. So a sequence is an arrangement of numbers in a definite order according to some rule. So how to think big in this sense? Now look at this. We have some set of numbers here, 5, and when you add 5 to it, it becomes 10. When you add again 5 to it, it becomes 15, then 20, then 25, and of course next would be 30 and next would be 35, isn't it? Dear children, while noting all these things, please make sure that you have your textbook with you and also a notebook in order to take down the notes. Then we have another sequence, 12, 12 plus 8 becomes 20, 20 plus 8 becomes 28, 28 plus 8 becomes 36, and of course the next one would be 36 plus 8, that is 44, and we can keep on continuing the number set till any number of our choice. In the other sense, it's an infinite sequence, right? So when a sequence has particular numerical number of elements or numbers, it becomes a finite sequence. And when you have lot of numbers with you which do not end at all, we call it as an infinite sequence. Now let us try to understand sequence in a different way. Observe this, the entire multiplication table of 1 to 20 or to any other number is again a sequence. Don't you think it? Now let us move on to a particular important aspect of our arithmetic progression. Arithmetic progression is a type of a sequence. So what makes arithmetic progression a different from sequence? Arithmetic progression is different from, or it is a part of sequence just because once you understand the definition of the sequence and once you understand the definition of the arithmetic progression, you will come to know what is a sequence and what is AP. Now let us see what AP is. An arithmetic progression is a special case of sequence where the difference between the term and its preceding term is always a constant, and that constant we call it as the common difference D. The arithmetic progression is abbreviated as AP. For our convenience we call it as AP, but you never find AP in any of the question papers. They will definitely completely give you arithmetic progressions. So in order to make ourselves in a very simple way, we call it as AP. So the entire chapter is based on this AP. What are all the characteristics of this AP? What and all we are going to study about more and more AP, that is the stuff of this chapter. Now let us move on to a few examples of AP. The very best example is what you can see is a multiplication table. Apart from that, there are different ways. That is 4, I add plus 6 to it, it becomes 10. Again I add plus 6 to it, it becomes 16. I add plus 6 to it, it becomes 22, and so on. So I am adding the common difference. It means to say that I have an arithmetic progression wherein the difference between two consecutive terms is always constant, like 10 minus 4 is 6, 22 minus 16 is 6, and so on. You might be thinking, is it necessary that in all the arithmetic progressions we are going to get the common difference as positive natural number? No, not necessarily. It need not be a positive integer. It can be a negative integer, it can be a rational number, or it can be an irrational number also. So for any value of D, we can have any arithmetic progression for that matter. Now let us try to see what is this general form of a AP. Let us try to understand with few examples. I have 10 and I have 7 and then I have 4 with me. So what is this? Is this a arithmetic progression? Of course, yes, this is an arithmetic progression. That is because once you observe, from 10 you have moved to 7, it means to say that you have subtracted 3, and from 7 you have moved to 4, in the same way you have subtracted 3, and then if at all you want to move to the next part of this sequence, which we call it as the term of a sequence, then I should end up with 1, isn't it? So, this is a particular number. In the place of these particular numbers, if I take some constants like a and d, how would this general form of a arithmetic progression look like? Now, let us start with a, and I will be adding a constant d every time. So, for this a, I will be adding a d, then it becomes a plus d, correct? Again, what should I add? What am I supposed to add? Since I am adding the constant term every time, I am supposed to add d only every time. So, for this a plus d, I will be adding one more d. Again, I should be adding d only, then I will be getting a plus d plus d plus d, and again if I add one more d, I will be getting a plus d plus d plus d plus d. So, can we write this in a other form or a simple form? So, the first term would be a, second term what we are writing, it would be a plus d, correct? Then the third term would be, there are two d's here which are like, therefore we can add both of them and obtain 2d. Then we have a plus 3d, and then we have a plus 4d, and so on. This forms the general form of an arithmetic progression. Okay. Now, let us move on to the question part. In your chapter, there are exercises and also few solved examples. I suggest you to go through the text once, go to solve problems, and then you take up the exercise problems. Now, let us look at the exercise problem. The first problem: in which of the following situations does the list of numbers involved make an arithmetic progression, and why? The taxi fare after each kilometer, when the fare is rupees 15 for the first kilometer and rupees 8 for each additional kilometer. So, what do you understand by this? There is a taxi and the fare of the taxi is for the first kilometer, the taxi fare after each kilometer when the fare is 15 for the first kilometer and 8 for additional kilometers. Suppose the taxi moves only for 1 kilometer, then what is the fare? The fare would be 15 rupees, right? Suppose the taxi moves 2 kilometers. What would be the fare? For the first it is 15, and for the next 1 kilometer it is plus 8, which is 23. Now, suppose you move 3 kilometer in the same taxi, then what is the amount that you are supposed to pay for the driver? So, it is first, for the first kilometer it is 15, the second kilometer is 8, and for the third kilometer it is 8 again. So, it is 31. Now, let us say you move some 4 kilometers, then what would be the fare? For the first kilometer it is 15, second kilometer is 8, third kilometer it is 8, and for the fourth kilometer also it is 8. Then it would become 39. So what are we interested in this problem? Observe that, does the list of numbers involved, what are the list of numbers involved here? The list of numbers involved here are 15, 23, 31 and 39. Now do you think there is an arithmetic sequence, or the set of these numbers follow arithmetic sequence? Of course yes, because from 15 you are adding it 8 to become 23, and from 23 you are adding 8 to become 31, and from 31 you are adding 8 to become 39. So it absolutely follows all the properties that are meant for the arithmetic progression. Hence this is an AP. So this is how you have to make the decision. Once you solve the problem, look at the numbers, look at the pattern followed, can you have that pattern in terms of AP? So this is how you make the decision. Now let us move on to the second problem. The amount of money in the account every year when rupees 1000 is deposited at compound interest 8 per annum. So every time you need to find out the simple interest. Simple interest is given by, simple interest is PTR by 100. And how do you find amount? Amount is always given by principal plus interest. So at the 0th time, since I have not deposited the money, I have the money with me, and that money is 10,000 rupees. I have deposited the money, and after first year what would I be having? I will be having 10,000 plus interest for 10,000 P into T, that is 1, T is 1 year, and 8 by 100. This amounts to, these two gets cancelled, this is 800, 10,000, 800. Now at the end of the second year, what would I be having? So since this is amount, okay, in the account year when 10,000 is deposited, all right. So I have 10,800. Since it is the compound interest formula, you need to take up the interest earned and you have to find the interest for interest, plus 10,800 into 1 into 8 divided by 100. So these two gets cancelled. Then I have 10,800 plus 864. That amounts to 11,664. Now look at the numbers. What are all the numbers I have in my list? First I have 10,000. Next I have 10,800. Then I have 11,664 and so on. Now let us try to find a pattern. Does this pattern match with the pattern of the IP? Now from 10,000 to 10,800 you have added 800, and from 10,800 to 11,664 you have added 864. Now we are getting it as a failure because as you can see, first time you have added 800, second time you are adding 864, which breaches the law for arithmetic progressions. Therefore this is not a AP. Now let's look for another kind of problem that has been enlisted in your textbook exercise. Write the first 4 terms of the AP when the first term A and the common difference D are given. So, here A, let us try to find the answer for the first one. A is equal to 10 and D is also equal to 10. You need to find the first 4 terms, right? First 4 terms. Now, let me call term 1 as A1. I will designate it as A1. A1 will be equal to A, which is equal to 10, isn't it? Now, let me move on to term 2. I call this term 2 as A2, and in the term 2 I have A, added to it AD, correct? A plus D, then it becomes 10 plus 10, which is equal to 20. Now, let us move on to the third term, term 3. I call this term 3 as A3, and in the general form that you have already seen, the general form, the third term is A plus 2D, which is 10 plus 2 times of 10, that is 10 plus 20, which is equal to 30. And again we want term 4, which is A4 equals to A plus 3D, that is 10 plus 3 times of 10, that is 10 plus 30, which is equal to 40. On the similar lines, you can find out the second problem solution also. Now, let us move on to the next one. So, I will choose a special number here. A is equal to minus 1.25 and D is equal to minus 0.25. So, the first term is nothing but A1, which is equal to A, it is 1.25. The second term I call it as A2, which is A plus D minus 1.25 plus minus 0.25, which is minus 1.25 minus 0.25, which will be minus 1.5. So, the third term A3 is equal to A plus 2D minus 1.25 plus 2 times minus 0.25, which is minus 1.25 minus 0.5, which will give you minus 1.75. So, similarly, you can find out the fourth term. So, in order to check your compatibility, whether with the same ease or with the same flow, are you able to do problems based on natural numbers, problems based on rational numbers, and problems based on integers. Of course, a number is a number ultimately, right? Now, let us move on to the next set of problems. For the following APs, write the first term and the common difference. The AP is given, the first AP is 3, 1, minus 1, minus 3. So, the very first term is always taken as the first term. So, A is equal to 3. Then how do you find the common difference? Common difference is always given by A2 minus A1 or A3 minus A2. So, the very simple trick is to take the back way here. So, this is 1 minus 3, which is equal to minus 2. So we have A is equal to 3 and D is equal to minus 2 for this particular question. Now let us move on to the second one. I will take up 1 by 3, 5 by 3, 9 by 3, 13 by 3. 1 by 3, 5 by 3, 9 by 3 and 13 by 3. So the very first term itself is A. A is 1 by 3. Now the common difference D is equal to A2 minus A1. So it is 5 by 3 minus 1 by 3. So it is 5 minus 1, which is equal to 4 by 3. So we have A is equal to 1 by 3 and D is equal to 4 by 3. On the similar lines, I think you can find out the other answers also. Let me take a simple question here which involves negative integers minus 5, minus 1, 3 and 7. So we have minus 5, minus 1, 3 and 7. We have A is equal to minus 5, D is equal to A2 minus A1. A2 is minus 3, minus is this formula, and A1 we have minus 5. Dear children, be careful in solving the problems of this type. In order to prompt you, I have chosen this particular problem because while writing this minus, you people, particularly the students, they tend to write 1 minus and they omit 1 minus. Therefore, it is minus 1 plus 5, which is equal to 5 minus 1, that is 4. So A is equal to minus 5 and D is equal to 4 is the solution for this particular problem. Now let us move on. We have one more set of problems in the first exercise. Which of the following are AP? If they form AP, find the common difference D and write 3 more terms. See the sub questions involved in this particular question. First of all, we have to establish whether the given terms are of the AP category or not. If they are of the AP, we have to find the common difference, and the third, then we have to write 3 more terms. So these are the questions that have been listed in your exercise. So let us start and take few examples and the rest of the problems for you to try it out at home as homework. Ready children? Okay. Now let us start with the first one, 2, 4. So we have 2, 4, 8, 16. Now in order to make this as AP, what you need to do is find any 2 terms, find the difference. I will take these 2 and I will take these 2. Now let me check out the differences. 4 minus 2 is 2, 16 minus 8 is 8. So the differences are different. We are not getting the constant difference. Therefore, the first one is not an AP. Now let us take up the fifth one, 3 plus root 2. The fifth one, 3 plus root 2, 3 plus 2 root 2, right, and so on. Now observe, take the differences of any 2. We have 3 plus root 2 minus 3, that is root 2, Next we have 3 plus 2 root 2 minus 3 plus root 2, 3 plus 2 root 2 minus 3 minus root 2 plus 3 minus 3 gets cancelled. 2 root 2 minus root 2 can be written as 1 root 2, which is equal to root 2. So, in both the cases I have got root 2 as the answer. Then I have 3 plus 2 root 2, 3 plus root 2, 3 plus 2 root 2, 3 plus 3 root 2, and the next 3 terms you can easily make out. 3 plus 4 root 2, 3 plus 5 root 2, 3 plus 6 root 2, so on. So, this makes an AP. Once it makes an AP, we can easily find the D, and once you have found out the D, you are supposed to write the next 3 terms of the given AP. So, that is what we have done. So, this is AP established here. This is root 2, we have already found it, and once we have found the common difference, we can keep on adding the common difference to get the next term. So, I have added 1 root 2. For this 3 root 2 I have added 1, it become 1 root 2, it becomes 4 root 2. Then I have added 1 more root 2 for 3 plus 4 root 2, it becomes 3 plus 5 root 2. Adding 1 more root 2 to 3 plus 5 root 2 yields 3 plus 6 root 2. So, do not be panic when you look at the irrational numbers. Once you dig deeper or once you think in a different way, you can easily find the answer and you can easily write the answer without any hesitation. Children, now let us take another example: root 2, root 8, root 18, root 32. Root 2, root 8, root 18, root 32. What do you think? Is it a AP? Let us check it out. So, once you look at the numbers, then you will not be in a moment or you will not be in a position to identify the terms of the sequence. Rather, let us try to write these surds in simple form. So, root 2, it will be as it is root 2. Now, let us write root 8. Root 8 can be factorized as 4 into 2. So, this can be rewritten as root 4 into root 2. So, root 4 is 2 and this is root 2. Similarly, root 18. In the similar lines, when you think of this, this can be written as 9 into 2, root 9 into root 2. Root 9, the value of root 9 is 3 and this is 3 root 2, and we have root 32, that can be rewritten as 16 into 2, root 16 into root 2, root 16 is 4, we have 4 root 2. And look at the pattern, we have root 2, we have 2 root 2, we have 3 root 2, we have 4 root 2, and it is very simple for you to guess the next 3 numbers. So, it is 5 root 2, 6 root 2 and 7 root 2. Now, can we write this in the given question form, like it was root 2, root 8, root 18, root 32. Similarly, what would be this? So, here it is 5, the square root of something is 5. What is that something? That is 25. 25 into 2 is 50. So, it is root 50. 6 6 are 36, 36 2s are 72, root 72. 7 sevens are 49, 49 into 2, it is root 98. So this is how you are going to break down the problem, solve the small issues, and then blow up the problem as it is given in the problem statement. Probably on the similar lines, I think you can try the other questions also. If you find it very difficult to solve any problem in this, we are ready to listen to your feedback and to respond to your feedback. Your feedback is very important to us. Don't forget to leave a feedback, leave a comment, or leave anything that you wish to have your say. Please respond to sp.kolar@gmail.com and we will be eagerly waiting for your responses. Hope you enjoyed this session. Thank you very much, children. Wish you good luck, and let us see in the second part of this arithmetic progressions video in the next video.